Okay, verifying inverses. So this is going to bring back like graphing. Hopefully you remember how to graph. Two functions are inverses if they reflect over that line y equals x. So here we have to find the inverse and then verify it graphically. So first let's find the inverse here. Oh, just kidding. First let's graph it. So we have 3x minus 6. Well, that's in the form of y equals mx plus b. So m is the slope, b is our y-intercept. So in this case, the slope is 3 and the y-intercept is negative 6. So I'm going to go down 6, and that's going to be my starting point. And then I'm going to go up 3 over 1, up 3 over 1, up 3 over 1, and then there's that line. Now let's find the inverse. So that's going to be x equals 3y minus 6. Add that 6 over, divide by 3. So that's y equals x plus 6 over 3. Let's break this up so it's a little easier. That's the same as x over 3 plus 6 over 3, which is the same as 1/3 x plus 2. Okay, so in this case, my slope is 1/3, my y-intercept is 2, so let's graph that one. We go up 2, slope is up 1 over 3, up 1 over 3, and then there's that line. Okay, and notice that if we were to fold these, let's first graph the line y equals x. If we were to fold right along that line, if you could take your screen and pull out that graph right there, and you could hold it in your hands, and you could fold over that line, those lines would fold right on top of each other, which means they're inverses. Kind of cool, okay? This one, so x cubed plus 4, well, that's what the x cubed graph looks like. So that plus 4 is just going to move it up 4. So we're going to go up 4. There's that graph. That's a very rough sketch. And then let's find the inverse. So x equals y cubed plus 4. Subtract the 4, cube root. So y equals the cube root of x plus 4, or x minus 4, sorry. That minus 4, so there's that cube root graph. And if you don't remember these, use your calculator. Okay, you have them. And then that minus 4 moves it right 4, so we're going to go right 4, and there's that. Draw our y equals x line. If you folded it, it would fold on top of each other, so we've proven it. Okay, now algebraically, it's a little weird, and I don't think we've gone over this notation yet. So we have g of f of x, or f of g of x equals x. We have to also prove that g of f of x equals x. Before I go any further, I just want to explain this real quick. So f of g of x. What this means is we're taking this and we're plugging it into f. So what I want you to kind of rewrite these. That's the same thing as f of g of x. So we take whatever g is and we plug it in for the variables in f. Okay, this other one, the g of f of x, again, that's saying we're taking this and we're plugging it into g. So that's going to be g of f of x. Okay, so we're just taking the function and plug it into the other. So let's look at this. We're given these two, and we want to see if they're inverses. So first, let's do f of g of x, which means we're going to take the g of x and we're going to plug it into f. So I'm going to take this and plug it in for that x right there. So you get 2x plus 7 minus 7 over 2. Well, we can get rid of the parentheses. They're not doing anything. So 2x plus 7 minus 7 over 2. 7 minus 7 is gone, so you get 2x over 2, which is x, which is what we wanted it to equal. Okay, let's do the same thing, but the opposite way. So now we're going to take this and plug it in for that x right there. So we're going to do the g of f of x. So it's going to be 2 times x minus 7 over 2 plus 7. Those 2's cancel, and you get x minus 7 plus 7. The 7's cancel, and again, we're just left with x. Okay, you always want to be left with x. And I know that you're going to be left with x. I need to see your work on these. Okay, if you just put like, yep, it equals x, that's awesome. No, you don't get credit. Okay. This one, so this is saying only when it's greater than 0. Yeah, that's just because the x squared graph, remember, it doesn't usually have an inverse, but if we restrict it to just when x is greater than 0, because this graph looks like this, if we go down 5, 1, 2, 3, 4, 5, that's what it looks like. But we're restricting this because this doesn't have, oh my goodness, why do I keep doing this? This doesn't have an inverse if we're looking at this function. But if we restrict it just to when x is greater than or equal to 0, so just that green part, that does have an inverse. Okay, so f of g of x, plug that in, so we're taking this and plugging it in there. So x plus square root of x plus 5 squared minus 5, which that goes away, x plus 5 minus 5 is x. Do it the opposite way. So square root of x squared minus 5 plus 5. Those minus 5 plus 5's cancel. It's the square root of x squared, which is x. Cool. We're going to save the back of those notes for class. Remember to take the quiz. I think this is the last video of the whole year if you are in my 2019-2020 class. So congratulations, we made it. Start studying for your final. Okay, bye.